In this video, we will discuss the kinds of thresholds that Big Eye supports for identifying anomalies in your data. Let's start with defining a threshold. Just like a literal threshold on a door separates two spaces, outside from inside, one room from another, a data threshold represents a point where data is no longer in an expected or acceptable range. Thresholds are represented in light gray color on a metric chart, and they represent the range of values where data points are expected to fall. Thresholds can be implemented for upper or lower bounds or both, but what exactly does that mean? For some kinds of metrics, you need to be alerted if things go too high, like security incidents. For others, you're more concerned about values dropping too low. Think daily sales. For others, it matters if things go outside of a generally steady range, like the value of a commodity. Big Eye supports a number of ways of implementing thresholds to identify which values are outside of the norm, even possibly concerning or indicative of some broken process. Here are some of the more standard methodologies for teams that know with reasonable certainty what they're looking for. First, let's look at the constant threshold type. Constant threshold types represent known ranges for acceptable values in a column. One example might be that a test score can be between 1 and 100, but not less and not more. Next, let's look at relative thresholds. Relative thresholds designate an acceptable percentage of increase or decrease from a selected reference point. Big Eye also supports standard deviation as a threshold type. Standard deviation allows you to select a reference window, which uses all data points in that window to calculate the mean. Then you can choose upper and lower bounds as acceptable deviations to the mean. Finally, the most intelligent thresholds that Big Eye supports are auto thresholds, which are generated when Big Eye trains a machine learning model on your own data to advise what is and is not anomalous. There are several advanced settings and many configurations that help define how this will work. Let's look at a couple of them. The training history, which defaults to 90 days, represents the number of days of history Big Eye uses to generate auto thresholds. The training frequency determines how often the models will adjust based on new data. And post hoc detection allows for the replay of auto thresholds over historical data to identify anomalies that are still present. There are many other advanced settings that can be configured with regard to auto thresholds. Within the user interface, specifically the metric configuration, you can select a couple of things. From sensitivity, narrow to extra wide, narrow alerting more frequently, and extra wide casting a more forgiving net, as well as bounds, whether upper, lower, or both. A neat part of using Big Eye's auto thresholds is the ability to make inferences about seasonal trending, provided our model is exposed to at least 3 or more cycles of a pattern within your data. This seasonality can be observed at an hourly, daily, weekly, or monthly range. An important part of Big Eye's auto thresholds is managing noise via the issue close feedback loop. When closing an issue or moving it to a monitor status, you can let Big Eye know whether it provided a helpful or not so useful alert. That way, Big Eye will either maintain or adjust the thresholds going forward to help you manage that noise to signal ratio. And finally, let's circle back to a concept we've discussed before, freshness. Let's explore the options available to us when we select the threshold type freshness. First, I'm able to define an update schedule. These can be defined using cron formatting, which uses 5 fields to represent minute, hour, day of month, month of year, and day of week. You may define some or all of these fields and leverage wildcards to indicate every possible option. There are lots of great resources on the web to help with cron if you're interested. The delay update denotes how stale the data will be at the time that it updates. And finally, I can define a time zone as an offset of GMT or as an abbreviation. I hope that in this video you have learned what a threshold is, what kinds of thresholds Big I supports, and how to implement thresholds in the Big I platform.